Kenny, tuki ka. Allow me to guide you in learning the different concepts and skills in Mathematics 9. I am Teacher Andrew, your soulmate. Ready your self-learning modules or learning activity sheets. A teacher paired up students in her class. Each pair was given a unique problem to solve. Denise and Regine, who call their team or tandem Pata team, were tasked to solve this problem. The sum of two numbers is 24. What could be the maximum product of the two numbers? What are these numbers? Denise messaged Regine, and here's what she said.
Reg, sinend ko dito yung ginawa ko ha para dun sa problem. Di ko na alam ituloy eh. Ikaw na bahala, no? Bye!
Reg saw the message but didn't reply. #Cinderella. What she did was screenshot the message of Denise and sent it to Rosary with a caption,
Salbabida friend, help! Heto yung problem na sinosolve namin. The sum of two numbers is 24. What could be the maximum product of the two numbers? What are these numbers?
To which Rosary replied,
Salba because I will save you, and Bida because mabait ako? Okay, wait.
Rosary, living up to her title Salbabida, called Reg via Messenger, and the two had video conference so that Rosary can better explain how to solve the problem. And this is how she explained it to Reg. Deng is right. She represented the two numbers correctly, x and 26 minus x, since their sum is 26. And Deng is right again with the function that she gave, because if we will write the product of the two numbers as a function of x, we can denote it as p of x, where p stands for product. And p of x is equal to x times the binomial 26 minus x. Or we can use y instead of p of x. Hence the equation y equals x times the binomial 26 minus x. The next step is, of course, to write the function in the general form. Y equals ax squared plus bx plus c. We have to multiply x by the binomial 26 minus x. So the equation will now become y equals 26x minus x squared. And arranging the terms in descending powers, the equation will be written as y equals negative x squared plus 26x. We can see clearly the value of the leading coefficient or of the coefficient a, which in this case is negative 1. If a is less than 0 or negative, it means that the quadratic function has a maximum value. This maximum value is the y-coordinate of the vertex of the parabola. So, we need to identify the vertex of the parabola so we can determine the function's maximum value. There's a way to identify the vertex, and that is by transforming the function into the equation y equals a times the square of the binomial x minus h plus k, where a is the leading coefficient, h is the x-coordinate of the vertex, while k is the y-coordinate. Hence, the ordered pair hk describes the vertex of the parabola. How do we do this? In the function y equals negative x squared plus 26x, there is no constant term. This means c is equal to 0. We may put plus 0 or minus 0. Next step is to separate the terms with the variable x from the constant term. Let us enclose them in parentheses. If the coefficient of the quadratic term is not 1, we have to factor that out. In this particular function we are working on, we have to factor out negative 1, meaning we have to express the binomial negative x squared plus 26x as the product of negative 1 and another polynomial. We divide negative x squared plus 26x by negative 1, in which the result is x squared minus 26x. Hence, y is equal to negative 1 times the binomial x squared minus 26x plus 0. Then we have to turn the binomial enclosed in the parentheses into a perfect square trinomial. How do we do this?
Lahat po tayo ay nagnanais ng maligayang Kapaskuhan at masaganang bagong taon.
First, we square the half of the coefficient of x. This coefficient is negative 26. Half of negative 26 is negative 13. Square of negative 13 is 169. Second, we add the result to the binomial in the parentheses. But we need to maintain the value of the quadratic polynomial in the function y equals negative x squared plus 26x. So, we have to subtract from the constant term the product of what we added to the binomial in the parentheses and the value of the coefficient a that is placed beside the open parenthesis. 169 times negative 1 is negative 169. So, we subtract negative 169 from the constant term 0. Let's express the perfect square trinomial enclosed in the parentheses as a square of a binomial and combine the constant terms. So the equation will become y equals the negative of the square of the binomial x minus 13 plus 169. And this is an example of a quadratic function expressed in standard form or vertex form. Let's compare this standard form or vertex form to that of y is equal to a times the square of x minus h plus k, so we can correctly identify the values of h and k, the coordinates of the vertex. X minus 13 versus x minus h. This means h is equal to 13. Plus 169 versus plus k. This means k is equal to 169. Therefore, the vertex of the parabola is the ordered pair 13, 169. So, the maximum value of the function y occurs when x is equal to 13. And this maximum value is 169. This number, 169, is the maximum product of the two numbers described in the problem. What are the two numbers? Since the maximum product is obtained when x is equal to 13, 13 is one of the two numbers. By substitution, the other number, 26 minus x, is equal to 26 minus 13, in which the result is 13. So, it appears that the two numbers whose sum is 26 and whose product is the maximum are just the same. Salvabida friend saves the day. A big hand for Rosary, everyone. But what can we say about Pata team? Denise did her part, but she was apparently not interested to work with Regine in accomplishing the task. As a partner, Denise should have asked Regine first if the latter knew how to do it. Regine, for her part, should have been honest to Denise that she didn't know how to do it. You see, they didn't work as a team. Let's learn from them. Let's be open to collaboration. No matter how small, we can contribute to the team. In the process, we will all learn from one another. At this point, let me give you some more examples on how to rewrite quadratic functions into their vertex form. Number 1, y equals 2x squared plus 4x plus 4. This function is in general form. The leading coefficient is 2, a positive number. When a is greater than 0 or positive, the function has a minimum value. The parabola's vertex is its minimum point. So we separate the terms with the variable from the constant term, hence the parenthesis. Next, we factor out the coefficient 2. Thus, y is equal to 2 times the binomial x squared plus 2x plus 4. Then, we square the half of the coefficient of x. 2 is the coefficient of x. Its half is 1. The square of 1 is also 1. We add 1 to the binomial enclosed in the parentheses, hence completing the square. And so, we must subtract from the constant term, positive 4, the product of 1, which we added to the binomial enclosed in the parentheses, and 2, the leading coefficient, written beside the open parenthesis. 1 times 2 is equal to 2. Hence, y is equal to 2 times the trinomial x squared plus 2x plus 1 plus 4 minus 2. Expressing the perfect square trinomial as a square of a binomial and combining the constant terms, the equation can now be written as y is equal to 2 times the square of the binomial x plus 1 plus 2. This is already the standard form or vertex form of the function y equals 2x squared plus 4x plus 4. So, what is the vertex of the parabola that represents the given quadratic function? Let's identify the values of h and k in the vertex form of the function. Recall that the vertex form of quadratic functions is given by the equation y equals a times the square of the binomial x minus h plus k. Let's compare x plus 1 versus x minus h. This means that h is equal to negative 1. X plus 1 is the simplified form of x minus negative 1. Indeed, h is equal to negative 1. Plus 2 versus plus k. This means that k is equal to 2. Therefore, the vertex can be written as the ordered pair negative 1, 2. This implies that at x equals negative 1, the minimum value of the function y is obtained, which is 2. Let's have another one. Y minus x squared plus 1/4 equals negative x plus 3. This function is not in general form yet. Let's isolate the variable y by eliminating the terms negative x squared and 1/4. We do this by increasing both sides by x squared and decreasing both sides by 1/4. The resulting equation is y equals x squared minus x plus 11 over 4. The leading coefficient is 1, the invisible one. It's positive. Hence, the function has a minimum value and the parabola's vertex is its minimum point. Let's separate the terms with the variable from the constant term. The leading coefficient is just 1. Thus, we can proceed now to completing the square. The coefficient of x is negative 1. Its half is negative 1/2. The square of negative 1/2 is positive 1/4. We add 1/4 to the binomial in the parentheses. And since the leading coefficient is just 1, we just have to subtract 1/4 from the constant term 11 over 4. This equation can now be rewritten as y equals the square of the binomial x minus 1/2 plus 5 over 2, where the value of h is 1/2 and the value of k is 5 over 2. Hence, the vertex is the ordered pair 1/2, 5 over 2. At x equals 1/2, the minimum value of y is achieved. It is equal to 5 over 2. Kagamath, ready your paper and pen. It's Math the Moment! Item number 1. Rewrite the equation y equals 3x squared plus 12x plus 23 over 2 in vertex form. Then, write the ordered pair that describes the vertex. For 60 seconds, go! Time is up. Separating the terms with the variable from the constant term and then factoring out the leading coefficient, y must be equal to 3 times the binomial x squared plus 4x plus 23 over 2. To complete the square, we add the square of the half of 4, which is equal to 4. Then, we subtract from 23 over 2 the product of 4 and the leading coefficient 3, which is 12. This can be rewritten as y equals 3 times the square of the binomial x plus 2 minus 1/2. This is already the vertex form of the function, and the vertex is described by the ordered pair -2, -1/2. Item number 2. Most cars get their best mileage when traveling at a relatively modest speed. The gas mileage M for a certain brand new car is modeled by the function m of s equals -1 over 28 times s squared plus 3s minus 31, where s is the speed in miles per hour and m is measured in miles per gallon. Question number 1. What is the standard form of the given quadratic function? For 90 seconds, go! Time is up. Separating the terms with the variable and factoring out the coefficient in the quadratic term, m of s must be equal to -1 over 28 times the binomial s squared minus 84s minus 31. We complete the square by adding the square of the half of -84, which is 1,764, to the binomial in the parentheses. Then, we subtract from -31 the product of 1,764 and -1 over 28, which is -63. This can be rewritten as m of s equals -1 over 28 times the square of the binomial s minus 42 plus 32. And this is already the standard form of the function, also known as the vertex form. Hence, the ordered pair s, m of s, tells us the mileage m of the car and at what speed s it is attained. Since the leading coefficient is negative, the function has a maximum value, and this value is the car's best mileage. Question number 2. What is the car's best gas mileage? And at what speed is it attained? For 15 seconds, go! Time is up. The vertex described by the ordered pair age k can answer this. Looking at the vertex form, the value of h is 42, while that of K is 32. Hence, the vertex is described by the ordered pair 42, 32. This means that the best mileage of the car is 32 miles per gallon, which is attained at the speed 42 miles per hour. That's it, Kagamath. Let me end on this note. Let our words be a function of our tactfulness in such a way that the more tactful we are, the careful we are with our words, so as not to offend anyone. See you in the next episode, Kagamath. Bye!